Hello everyone, this is Vandita. I'm studying in Sri Venkateshwara College of Engineering. I'm here to talk a few things about theory of computation. Today we'll be discussing the topic minimization of DFA. Okay, let's go into a topic. We'll discuss what is DFA and we'll solve numerical problems relating to DFA. First, let's see the definition of minimization of DFA. DFA minimization stands for converting a given DFA to its equivalent DFA with minimum number of states. DFA minimization is also called as optimization of the DFA and uses partitioning algorithm. So, by this definition, we have known that the conversion of DFA to its equivalent DFA in minimum number of states is called as minimization of DFA. Minimization of DFA means reducing number of states from the given FA. Thus, we get a finite state machine. So, this is the definition of minimization of DFA. Now, let's take a numerical example. This is a numerical example where I have taken here. This is the start state. This is the start state Q naught, and this is actually there are two final state, one is Q3 and another is Q5. The double circles indicates that it is a final state. The arrow mark includes the connection, the direction, flow of direction, like this is from Q1 to Q2 it is 0 and Q0 to Q1 it is 1. There is a connection between these states. This is the problem. Let's see the steps to solve the problem. In the step 1, in the given DFA, Q2 and Q4 are unreachable states, so we'll remove them. Here this is Q2 and Q4, this is Q4. These states are unreachable states because there is no flow of direction to Q2 and Q4. There is only direction from Q4 to other states, and but there is no to Q4. That's why we remove these states. Next, we draw the transaction table for rest states. So, rest of the states we have drawn the transaction diagram state. This is Q naught is initial state. The star here indicates the final state. Q3 and Q5 is final state. We have removed Q2 and Q4. So these states have been removed. That's why they are not added in the table. So Q naught, from Q naught, according to the table, we have a connection 0 and 1. From Q0 to 0 we have Q1, from Q0 to 1 we have Q3. In the similar way we need to mark for Q1 to 0, Q1 to 1. This is the second step. In the final stage we get this table, and in the third step now we divide the rows of the transaction table into two sets. First, now in the step 3 we divide the produced rows into two sets. First set, one set contains those rows which starts from non-final states and other set contains from final states. This is the table for non-final states. These are not final, as we have seen before. uh, uh, Q5 was a final state, so this is the non-final state. Next, in this is a final states. Q3 and Q5 were the final states. So these are two tables. Next, in step 4, set 1 has no similar rows, so set 1 will be the same. So in the set 1 in the previous table there were no similar values, that's why it will remain as it is. Here, as we can see, there are similar values. So in step 5, in set 2, row 1 and row 2 are similar since Q3 and Q5 transit in the same state on 0 and 1. So skip Q5 and then replace Q5 by Q3 in rest. Here, since these both states have same numbers, you can skip either Q3 instead of Q5, like you can replace Q5 as Q3 or you can either replace Q3 as Q5. This is step 5. So we'll obtain this table where you have converted a Q3 as a Q5. Now in this set we have done Q3 equal to Q5. That is the reason here in the place of Q5 we have put Q3. Next we'll combine set 1 and set 2. Set 1 had a Q1 and Q3, and set 2 had Q3. So Q0 and Q1 is 1 and Q2 Q3 is 2, set 2. So these are the values for 0 1, like for initial state. Q0 is termed as initial state because of the arrow mark, and Q3 is termed as final state because of the star symbol. So Q0 to 0 it will be Q1, Q0 to 1 it will be Q3, Q0 Q1 to 0 it will be Q0, Q1 to 1 it will be Q3, and Q3 to 0 it will be Q3, and Q3 to Q1 it will be Q3. So now we have obtained the final table for our transaction diagram. So now it is the transaction diagram. So from the before DFA we need to construct the diagram for minimization DFA. This is, as we have discussed, it is the initial state. This is the final state which is been marked with 0. I mean the star symbol. Here from the table we have just done the marking. From Q0 this is the start state. From Q0 to Q1 it is 0. From Q1 to Q0 it is 0. From Q0 to Q3 it is 1. From Q1 to Q3 it is 1. Q3 is double circle because it is final state, and there is a loop self loop for 0 and 1, which indicates whichever 0 and 1 we apply on Q3 it gets self looped. But in the other states, if we apply 1 here, Q1 is moving from Q1 to Q3. In similar way, when we apply 0 on Q2 it is moving to Q1. But if we apply 0 or 1 in the state Q3 it will self loop on the state. So this is an example for minimization of DFA. Hope you have understood. Thanks for watching. Please do like, share and subscribe.